we ready for it. Uh, with that in mind, though, we are continuing off day 5 of our IEEE comp. The title's really long. The IEEE Summer School for Computational Development of Games. Um, and we've got Andrew still here. Andrew's going to be discussing Unreal now, bringing the character over and doing that sort of thing. And on that note, I'll pass it over.
Yeah, welcome back. So yeah, this second half is going to be weighted more towards the technical side, the Unreal side of things. But before we get there, since I didn't quite get as much as I wanted to get done in the first half, and the Unreal portion is admittedly probably like, I want to say like an hour's worth of content. Um, I do want to kind of stick with Maya for a bit here and finish up this animation, and then we can jump over to Unreal. So as long as we dedicate at least an hour to the Unreal side, we should be good. So I'm going to kind of maybe move through this part a little bit faster. But generally speaking, you can kind of consider what we did up to the break to be what I would call like primary animation. So when I was talking about working at Bardell and the animation was broken into like the different phases where we get like 2 weeks for layout, 2 weeks for primary, 2 weeks for secondary. What we did with our animation here is essentially like primary animation. So now you can kind of consider what we're doing uh, right now. This next portion is the secondary animation where we spline our animation out and kind of start to kind of smooth out the details. So the process behind that is essentially just grabbing all your controls. And this is where we're going to start using the graph editor. So the graph editor is essentially a tool that shows all the animation for each control in a graph on all the axes. So depending on which axes you've keyed and where there's a change in value, you'll see a change in the curve. So because our main character is COG, has a change of, let's see if I have the right control selected here. Yeah, I do. You see this graph that actually has a change in value. That's because there's the actual change in value in our character themselves. So basically at this point, once you've got like a certain number of keyframes on the timeline here, you can grab all the controls and convert them to stepped, which is what we have here. So we see these flat lines. That just indicates that from this particular point until this point, the pose is held. But we want to have actual smooth curves. So if we just grab everything, grab all our keys, and then we can just hit auto tangent. Now we have actual curves in there, and we'll see our character is actually animated. So often when you go into spline, your animation doesn't necessarily look as good as it did in stepped. That's pretty common. It's just because, I mean, there's the main reason is because like you've worked out the timing based on poses being held for a duration of time, and now that period that where the frame is held static no longer exists because Maya is now interpolating from one frame to the next. So you may have to rejigger things a little bit. We're not going to spend too much time with that, but yeah, secondary is definitely like something that I would, dedicate more time than I'm going to dedicate to right now. But I just want to kind of explain generally how it works. When you go from step to spline, your work often doesn't look that great. And you have to kind of rework things a little bit. So I just want to fix some areas where things move a little bit too quickly. So in between 23 and 28, there's a bit of a quick movement there that I want to retime a bit. So I'll just grab all those frames, maybe move it back by a couple frames. And here as well, there's a bit of this is a bit faster. Let's move this over by 1 frame. And let's just take a quick look at how that looks. Yeah, it's still kind of jumping down a bit. Let's see. Maybe in there we can retime things a bit. Let's pull this over a bit. And what I'll do here is it kind of looks like the body comes up and then the arms come up much, much later. So if I actually grab those two shoulder controls here and just fully delete this frame, then we'll have interpolation happening between frame 43 and 60. So if I just delete that, we'll get a smoother blend of the shoulders and the body. And you know what? Let's actually just grab this entire arm chain as well and just delete these keys as well. So often the process of getting your animation to look the way you want it to again in secondary is addition by subtraction. So you're actually removing some keyframes you may have made. You're making new keyframes and just trying to smooth out the kind of rough edges. So another part that I'm not loving is this section here where the arms just kind of reach out. I kind of want them to start reaching out from frame 0 instead. So I'll just remove that and see how that looks. And another thing you can do in secondary is actually start offsetting your animation a bit. So I'm still getting a weird thing where he lifts his body up here, and then only when he reaches the apex do the arms start coming out. So I'd actually want the arms to start coming out before he reaches the apex at frame 60. So that would mean I have to like pull all these keyframes back a bit in order to get that motion happening the way I want it to. But before I do that, I want to do one other thing, which is essentially, if you look at the range of time here from frame 0 to frame 60, we only have curves in this range, but I actually want to loop these curves uh, after the fact. I want to actually have these curves just loop beyond frame 60 and before frame 0. And I'll explain to you why I want to do that. So if I just grab all the keyframes and I go to curves, I go to pre-infinity and I hit cycle, you'll see that now we have this kind of faded curve that's just looping the animation we have here. And I'll do the same thing for post-infinity. I'll cycle that and the same thing happens. So now, even though we're not seeing outside of this range of time, we do have motion. If we were to actually extend our frame range or pull our time slider beyond, we'll see the motion continues to infinity. So the reason I want to do that is because if I now grab these arms again, I can offset them and be ensured that everything, once this gets offset, like if you notice when I pull it, I offset it, you see now this motion that was initially before frame 0 is now carried into the range of time that we actually have blocked off. So there's going to be motion in there now. Before we set it, when it was set to, I'll just go back to the way it was before. When it was set to constant, if I drug these frames and if I offset them, you're just going to have a static pose in there. So there's going to be no motion. So that's the reason why I want to make our pre-infinity and post-infinity cycle instead. So now that I have the arms selected, I can offset them so that they rise up, because our initial goal was to have them rise up before RAF reaches its apex. So now we can see that happening right from frame 51. We're starting to have the arms rise up a bit. And that's just going to create like a little nicer overlapping feeling. The issue though is that the arms kind of drop down a bit early. So what we can do is we can grab this section and pull it back a bit. Oops, sorry, went the wrong way. It was happening too early, so we actually have to pull it forward. So let's pull all this forward. And we'll offset the torso a little bit too. We'll grab these torso controls And so that when he drops down, we'll have his body bend forward a little bit after his overall hips start to drop down. So we'll just grab all the curves here, maybe offset them by like 4 frames. And let's just delete this frame to get a little bit of a smoother motion happening. And the arms are still dropping just a little bit too soon. So I'm just going to go back in one more time and yeah, right here they drop down too early. So I want that torso to start dropping, that upper torso to start bending forward before these arms start dropping down. So I'll just grab all of these and pull them forward by like 5 or 6 frames. And then where they jump up here, it's a bit quick. So I'll just move that to like frame 56. Actually, one thing. Grab both of these. Okay, it's not perfect. Definitely needs a lot more work, but let's just call that done for now so we can keep moving forward. I'll save that out. Now we might come back to Maya if we have time to build out a walk cycle, but I do already have one pre-made that I think will work for our project. So let's do some Unreal stuff before we do too much more Maya stuff. So the first thing we want to do is, let's save this. We want to export our animation in a format that Unreal recognizes, and that format is the FBX. So for our animation files, all we need to do when we're exporting is select the entire skeleton and then export that as an FBX. So what I like to do is create a selection set for the skeleton. So it's just easy to export quickly. You don't have to go and always find all the skeleton bones and select them. So if we go into our outliner and we just show joints, that will just give us our joints. There they are. So yeah, if I just select this joint group and I go select hierarchy, that will select everything that's underneath this this group here. So again, I'll go create sets, quick select set, and I'll call this one skeleton and hit OK. And the other thing we need, besides just our animation, is we need to export a skeletal mesh. So a skeletal mesh is basically just the combination of the bones and the mesh itself. So it's basically a mesh bound to a skeleton, which can be animated. So that's the other asset we're going to need to bring our character into Unreal. So we have the joint selected. We also want to select all of the geo. So let's go back to show all. And if I'm just going to drag this shot camera off screen. If I make geo selectable by turning off that reference button, we can find one piece of geo, and then the group is, geo 1. So if we select geo 1 and we also select the joint group, because we need both the joints and the geo, again, we go select hierarchy, we can go create sets, quick select set. And this one we're going to call scale mesh. So now we have two selection sets, one for our one for our skeleton and one for our scale mesh. So first things first, let's export our animation. Now, nice thing about Maya is it actually has a game exporter button that allows us to just pretty easily export our scale mesh and our animation. So let's start with the animation itself. So we have three tabs up here in our game exporter window. I only deal with the model and the animation clips one. The model is for exporting a scale mesh. The animation clips is for animating or for exporting the animation. So we'll click the plus icon to create a new file. Naming conventions in any work are very important. You know, when you're working on a team, you want to make sure you guys are adhering to a consistent naming convention. So with Unreal, I'm going to adhere to the overall, the generally accepted, the widely accepted animation, naming convention that's utilized by everyone by every studio that I've worked for that uses Unreal. So we'll start with a underscore, and this is a RAF idle, so we'll just call it RAF idle. And it's 60 frames. We'll just export it to our desktop as well. And we'll export it as a FBX file. We'll call it, sorry, this is just picking the folder, I think. Yeah, okay. Actually, we'll do RAF underscore idle. That's a little bit cleaner. Okay, and then we have settings. We don't need to change any of this. We can just hit export. Oh, one thing we need to actually change. So yeah, I created that selection setup here. That's where that comes in handy is right here when we're choosing what to select, what to export, excuse me. So here you can just export all. You can export what you have selected, or you can export the object set, which will allow you to pick your selection set. So this is an animation. We just need the skeleton. We'll select skeleton. We'll hit export. And the export's successful, so that's perfect. So the next thing we want to export is our skeletal mesh. Before I do that, I'll just put Raph back in his default pose because I think that's going to be a better way that's a better pose to start to export from. So if I just select everything, and I actually have a tool that allows me just to zero out everything. There we go. So now I just zeroed out my character. I will undo that because this file is actually an animation file. I don't want to save this pose here, but just for the purposes of exporting the skeletal mesh, I'll just I'll set it to 0, and then I'll just undo this pose that was just set. But usually I'll export a scale mesh from like a clean Raphael scene without animation on it, but you still can do it from an animation scene. I would just recommend making sure your character is in a default pose. So same thing here, we'll go to our object set. This time we'll select scale mesh, and we'll choose our export directory, which is going to be our desktop again. And the file name will be, so for skeletal meshes, we prefix it with sk underscore. We'll just call this RAF. And yeah, everything else is fine. So we'll click export. Oh, I already have one? Okay, I guess I already had one on my desktop. So I'll just call this one 02. Or I'll call this one RAF TRU. We'll hit export. Actually, yeah, export set. Okay, perfect. Hit export. Export successful. Okay, cool. So now let's open up Unreal. So for those of you who've never used Unreal before, we'll initially be prompted with this Unreal project browser here. So this is all the projects you've currently made. If you go down to games, you have some templates you can work from. We're going to work from the third person template. So we'll select that. We'll keep this set to blueprint. Target platform is desktop. Yeah, quality maximum. I think starter content is default on, but we don't really need that. I don't think we need that. So we'll just leave that that unchecked, and we'll call this TRU demo. You can change the project location if you want. I'm just going to leave it there. And then we'll create our project. So we'll do a very quick tour of Unreal as well. It's pretty similar to Maya in that you have your workspace, you have your outliner over here. So this is just a list of all the objects in the scene. And then based on what object you have selected, you'll have a details panel where you can change those parameters. So that's kind of like a mashup between the channel box of Maya, which is this guy here, and the attribute editor. So it's fairly similar. Even navigating around the scene is similar to Maya. So you, I don't know if I mentioned this in Maya, but to navigate around your scene, you just hold down Alt and use any of the mouse buttons, left mouse button to rotate, middle mouse button to pan, and right to zoom, which is basically the same in Unreal. However, some things are inverted, like the panning is, I believe it's inverted. Let me just check. Yeah, it's when I'm pulling to the right, it moves, the scene moves to the left. So there's a couple settings we can change in our editor preferences, which will make it function even a little more closely to Maya in terms of navigation. So a couple of the settings you might want to change are invert middle mouse pan. So that's when I was holding middle mouse button and holding Alt and dragging, it was inverted. So if I actually, or yeah, if I now set invert to true, it will feel the way Maya feels. And if you've worked in Maya for a long time, you kind of want to reproduce that feeling. So that's what these settings are going to do. Another one is enable arc ball. So that's just where if you select an object and you hit E to rotate, oh God, frame in, you can actually select, usually by default, you can only select the individual axes to rotate the object. But with enable arc ball turned on, you can like rotate the whole thing in the middle. Few more settings I want to change are enable screen rotate. And if you just hover over it, kind of explains what the changes are. So this allows a screen rotation with the rotate widget. Two more. Oh yeah, that was it. Left mouse button drag does marquee. That I definitely want. That allows us to drag and select multiple objects. And the final one is orbit camera around selection. Excuse me. So with those all changed, you can just set those as your default. Yes, I want to update these. Not currently writable. I'd like to make it writable. Yes. And they've been updated successfully. Okay, cool. So now, yeah, this feels more like Maya. Okay. So, oh, there's one thing I do want to mention. So once we get into more like blueprint related stuff, a lot of my learning of Unreal just came from trial and error and my own research online. But one individual who was really helpful in my learning process and whose lessons I actually am using for some of what I'm going to show you here is a guy named Skylar Sura. He's the principal animator over at Riot. And he was kind of like my gateway into gameplay animation in Unreal. So I do want to give him a shout out because he was very influential in my learning of Unreal. And I can point you to some more resources that he has that expand upon some of the stuff that I'm going to show you here. So Yeah. Um, okay. So what's next? Down here is the content drawer. This is where all the folder structure for all your assets within your project. So we're going to kind of live in the characters folder, and we're going to create a new folder in characters called RAF. So we just right click, new folder, we'll call it RAF. And we'll create 3 folders inside this new folder, or this RAF folder. And we'll name the folders mesh, anims, and materials. So the first thing we want to import is our skeletal mesh. So we'll import that into our mesh folder. So you have an import button here. You also have an import button if you right click up here. So you'll open up your browser window here. We saved our scale mesh to the desktop. So by default, this is going to give you an option for all of your files. We're only looking for FBXs. And actually, I ran into an issue. So just keep this in mind. I ran into an issue when I was trying to import scale meshes and animations from my laptop. I'm not sure if it's an issue with Windows itself, because I think I have Windows 11 on my laptop versus Windows 10 here. But essentially, the issue is if you just try to import your skeletal mesh without changing this dropdown to specifically point to FBX skeletal meshes, your Unreal will just hang, like it will just freeze, and your import won't work. So just be aware that if you're trying to import your skeletal mesh and Unreal is just freezing, the fix I found was to actually make sure that if you're importing a skeletal mesh, you want to make sure that you, under the drop down here, select skeletal meshes. And conversely, when you're importing an animation, you want to select FBX animation. I'm pretty sure like they're both FBX formats, but for some reason they give you an option for FBX animation versus FBX skeletal mesh. I'm not positive that if you set it to FBX skeletal mesh and try to import an animation, that the animation will freeze Unreal. But I would just recommend setting it to skeletal mesh when you're importing a skeletal mesh, and animation when you're importing an animation. So let's grab our SKTRU and hit open, and we get a little pop up here. If it's your first time in Unreal, I just recommend clicking reset to default to make sure everything's defaulted. Don't need to change too much. Skeletal mesh ticked on, import mesh ticked on. Everything else here is fine. Create new materials. Yeah, we can leave that. And if we click import all, hopefully things work. Okay, sweet. So we got 5 new files in here. So even though we were trying to just import our skeletal mesh, we got a little bit more than that, which is what we want. So if you look here, we have the actual skeletal mesh file. It says skeletal mesh at the bottom here. We also have a physics asset, a skeleton asset, a texture, and a material. So the first thing we want to do is, like I said before, make sure we're adhering to proper naming convention. Naming convention is something you want to almost treat like a hard rule, like just a law. Don't ever break it, because it's really going to, as your projects expand, you want to be able to organize your files in a way that makes sense to not only yourself but the team as a whole. So I can provide you a link with that lays out proper Unreal naming convention, so that you can make sure that you have that ingrained in your head. Skeletal mesh is already prefixed properly, SK. The physics asset, we want to change to just, rather than have SK, that's going to be PHYS. For the skeleton, we're going to prefix it with SKEL. And for the material, we're going to prefix it with M underscore. And the texture will be T underscore. So you make sure you take the time to do this, because as your projects expand, it's really going to make things more clear in your mind about where things are and what they are. So now that we've got our files named properly, let's grab our two textures, or sorry, our texture and our material, and drag those into our materials folder. And then we can leave everything else in the mesh folder. We'll import an anim shortly and put that into our anims folder. So let's just quickly open up our skeletal mesh and make sure everything's looking correct. So this looks pretty good. We can see that we have our mesh itself. Over here, you can see that the skeleton is also shown. Sometimes when you import a skeletal mesh, the textures won't be applied. The materials won't be applied to the character. In which case you can jump into the materials editor and apply those. I'm not going to jump into that. I've only done it once, so I wouldn't really be able to demonstrate it very well, but it's very simple. You can find, lots of resources online to show you how to do that. Ours were applied automatically, so that's perfect. So not much else to look at here. We have our skeleton and our physics asset. So we don't really need to look into either of those. Materials, we can just leave those. The next thing we want to do is let's import our animation. So import, let's make sure we have our FBX animation. There's one for FBX meshes and animation, so maybe that's the one you want to use for either of those, but I'm just going to go with animation for now. And we have RAF idle. We'll open that, reset to default. So here, when you import an animation, you have to choose the skeleton to which you want to apply it to. So if we do the drop down here, we see there's a whole bunch of skeletons. We want our RAF skeleton, so we'll click that one. In the transform here, sometimes when you import an animation, it imports at a weird orientation where like the character is on their side or something. So if that is the case, you can change the rotation on any of these axes. I believe it's X, Y, and Z. If you drop down, yeah, you can see X, Y, Z. But if you don't do that at the outset, you can still do it after the fact. So if we scroll down, yeah, nothing else needs to be changed here. Let's just click import all. And we have an issue. Fail to import. Why did it fail to import? Let's see. Mesh contains skin bone as root, but animation doesn't contain root track. Weird. Let me just try that one more time. FBX animation, RAF idle, open. Yeah, skeleton. Let's just try import. Okay, weird. Let's just try re-exporting our re-exporting our animation file. Let's just go back to our anim tools, select that. And you know what, before we do that, actually, we'll bake out our keys so that there's a key on every single frame. Let's go edit, we go to keys, bake simulation, and we'll just bake. Okay, so now we've got animation on every frame. Okay, let's just recheck our selection set. Okay, select, quick select set. Actually, we'll go select hierarchy. Yeah, okay, so we got the skeleton. Let's try exporting again. It wouldn't be game development if things didn't break or cause issues from time to time. Let's go back here. Desktop. This time I'm going to select, go to export selection to export what I've actually got selected. RAF idle. Yeah, 0 to, actually, yeah, 0 to 60. That's the right frame range. Bake animation. Export. Let's overwrite it. Okay, if we go back into Unreal, let's try import. Go to animation, RAF idle. Our skeleton. We're still getting an issue. Let's check that error out again. Import failed. Geometry. Mesh contains skin bone as root, but animation doesn't contain the root track. Okay. I think I might have to revert to a backup. I'm not quite sure why this particular one isn't working, but we want to. I have a backup where with a skeletal mesh and animations that do in fact work. So what we'll do is we'll just go to that. We'll go to that file instead, or we'll use those files instead. So let me just navigate to where those might be hiding. I have had errors before where I can't import, and I'm just it's escaping me as to how to fix it, and I don't want to spend too much time on that. So I'll just go to a project I made previously with all the Raphael assets, and hopefully that one works. Let's see. So source assets, ops, Raf, ranks, FDX, and okay. So what we'll do is we'll open up. Let's see. Let's open up a different Maya scene. So we'll open up a different idle scene that I built before. And we'll skip that. Oh, hang on a second. Oh yeah, this one. Sorry, this is the wrong idle. Let's open up armed idle. Don't save. Okay, so here's another idle I built before. Okay, so we'll use this one, and we'll also okay, let's just export this animation. This might, hopefully this animation works with our current skeletal mesh. So let's go to our game exporter. And we have RAF armed idle. We're going to put this on our desktop. The frame range is going to be 80 frames. Let's see. Yeah, okay, cool. We'll set this to our desktop. And choose that. And we'll actually just overwrite the animation file we already have there. So export a skeleton, a RAF idle, 80 frames. Export. Yes, we want to overwrite it. Okay, hopefully this is going to work. If this doesn't work, it might actually be a problem with our skeletal mesh. But let's just cross our fingers. So import FBX animation, RAF idle, RAF skeleton. Okay, cool. This one seems to have worked. So I don't know what was wrong with that other Maya scene. But yeah, game development, there's weird things happen sometimes. Sometimes it's, yeah, it's just, that's what's, you have to just be expecting it almost. So let's open up our animation file. And as you see, yeah, see here, Raph is lying on his back. So as I mentioned, sometimes your animations import at a weird orientation. So I could have changed the orientation at that initial import option box, but you can also do it in the animation file itself. So if we just scroll down to import or transform, we can change the, I believe it's X to 90. So rotate him along X by 90, and then just click re-import animation. Yeah, we're still getting some like little notifications, but we can just ignore these. They're not going to cause any issues. So now we see that Raph is looking the way he should, which is great. Okay, so now we got an animation in our game. And you know what? Since we're in the animation importing portion of this, let's just go ahead and import our run animation as well. So, like I was mentioning before, how I was thinking of building an animation, but let's stick with Unreal now. I've already got a run scene pre-built, so let's just go with that one instead. So I'll just open up. Let's go. I think I have is it a run? Yeah, run forward. I'll open that. Don't save the changes. And this is our RAF running scene. Okay, so let's just quickly export this. Yeah, I even have the these all set up as well. So we're just going to export RAF run forward, and I'll just call it RAF run for now. And I'll overwrite. Actually, no, I don't have any file on my desktop called RAF run, so I'll just create one now. RAF run. Oops, this is just selecting the folder. So yeah, desktop, RAF run. That's all fine. Skeleton, yeah. Export. Awesome. So back to Unreal, let's bring in our run animation. Import. FBX animation and RAF run. Skeleton, import. Sweet. We'll change that to 90. Re-import. And there we go. So this is the animation. When we double click our animation, this opens up our animation file. And you just want to make sure that everything is looking the way you expect it to. Sometimes when you open this up, you might find that like maybe the arm isn't rotating the way you expected it to. And that might be because your skeleton for some reason isn't including a shoulder joint that the Maya skeleton does have. In which case you have to make sure that that full skeleton, the way it was, the way it's laid out in Maya is matching with the skeleton that is in Unreal. So just take a really close look to make sure the animation is matching, which from my perspective, I believe it is. So one thing about Unreal is that that's different from Maya. So if you look at the running scene here, and just ignore that there's no textures right now. I think yeah, I won't bother hooking up the textures. It's not really relevant at this point. But as you see, like when you're scrubbing through the timeline here, we're hitting full frames. We're going from 0 to 1 to 2 to 3 to 4 to 5. In Unreal, when we scrub, you can see that if you look right here, we have our frame 1, and then it jumps to frame 2. But if you look between frame 1 and frame 2, Raphael is actually interpolating. So Unreal, by default, when you bring an animation in, will fill in movement between your whole keyframes. So it's basically adding movement on frame 0 or 1.2, 1.3, 1.4. And I personally don't really love that. I mean, generally speaking, more frames per second in games is better, but at least when I'm working at this stage, I want my animation to literally look as it looks in Maya. And with this motion that's happening between frames that I'm not seeing in Maya, like if we go between 0 and 1, we're just getting one pose change. That's what I want to see in Unreal. So if I go up to the top here, I can just change the interpolation from linear to stepped. So that just ensures that we're only seeing a change in motion on whole frames. So you see 5 to 6 to 7 to 8, rather than motion happening in between those. So that's just going to make it look a little closer to what we exported from Maya. So I will save that. And I'll do the same for my idle as well. Set that to stepped. Excuse me. Okay, so it looks like our animations are looking good. So just to show you, when you initially create this third-person template, we have this play button up here, which allows you to play the game, the template itself. So if you haven't seen that, when you click play, we now have control of Quinn, and we can run around our scene and jump, and that's about it. This is meant to be used as a template, a building block, where you build upon it. So the first thing that we want to build upon is swap out our Quinn for Raphael. So to do that, we have to access something called the third person blueprint. So if we go up to our top folder here and then search for BP third person, we can open up our blueprint. So if you've never seen a blueprint before, this is what it looks like. It allows you to set up all sorts of logic, node-based logic, and connect those via pins that control the flow of the logic. So we're going to be mainly using two types of blueprints today. We're going to be using the third-person blueprint, which is going to be for some of like the more non-animation related logic for our character, and then we're going to be using the animation blueprint, which is logic that pertains specifically to animation related things. So this is a quick glance of the third-person blueprint. Let's see, do I want to show you the animation blueprint first? I think, yeah, let's take a look at the third-person animation blueprint first. So this is our third-person blueprint. Let's quickly go back and create a different type of blueprint, which is the animation blueprint. So I want to create that in the anims folder. So actually, I'll create it in our mesh folder and bring it to the anims folder, because the animation blueprint is based on our skeleton. And because our skeleton lives in our mesh, we want to be in our mesh folder. So if we right click on our skeleton, we can go create anim blueprint. And now we have an animation blueprint based on this skeleton. The prefix for animation blueprint is ABP. Let's close this. So let's open up our animation. Actually, first, let's move our animation blueprint over to our anims folder. And let's open it up. So again, similar blueprints layout here. This one is specific to animation related stuff. So what we have here is an output pose, and we have all this space here where we can add nodes to connect to our output pose. So generally speaking, we want to create nodes that allow us to visualize our animation. So in order to add nodes, you just right click in the space here, and you can add all sorts of nodes. I often know the node that I want to add, so I'll just start typing the name of it. And the first one we want to add is a reference to our animation that we brought in. So the idle animation. So if we search for play idle, you can see we have play a RAF idle. You click that, and then we get a node here. So if we now connect this execution pin to the result here, and we hit compile, we'll see that our character over here is now in idle state. So we have our first animation set up. So let's jump back to our character blueprint for a moment, our third person blueprint. So I should have just left it open. But it's not too tough to reopen. Okay, so what we want to do now is we want to, as I was mentioning before, we want to replace that Quinn character with Raphael. So in order to do that, we go over to the right-hand side here, and as long as we have under our components, so the components are just things you can add to your blueprint. So we have our character, we have the mesh for our character, we have a camera. We can also add things like props or effects or whatever. We can add all sorts of stuff in here. But what we have here under our components tab is probably enough for now. If I actually double click on the character, third person character, we can actually see Quinn, and we can see the camera behind her. That is the camera that we look through when we hit play in our workspace. So let's swap out Quinn for Raphael. So if we go over to the right here under details, we have skeletal mesh asset. Let's swap that to Raph. So now we have Raph in there. The other thing we need to swap out is the animation blueprint that Raph is using. So if we go up here, we see under animation, we have animation mode, use animation blueprint. That's what we want. Anim class right now is using animation blueprint Quinn. So we don't want that one. We want ABP Raph. So once we slot that in, we see that now Raph is in his idle pose. We can hit compile and save, and we'll just minimize that. So now if we go back to our workspace and hit play, now we have Raph. And he's running around our scene the way Quinn was, but obviously he's not actually running, he's just in his idle pose. But we're getting closer to where we want to be. So just hit escape to exit out of that. So the next thing we want to do is start building out more of the animation. So we have our idle playing, fine. We also have a run. We want to utilize that as well. So we want to actually make Raph run when we're hitting W on the keyboard. So that all that stuff happens in the animation blueprint. So if we go back to our animation blueprint, we're going to disconnect our idle animation. So to disconnect a wire, if you hold down Control and click on the wire itself, and then click again, we've now disconnected it. So we'll just move that up there. So what we actually want to connect to our output pose is not an individual animation, but something that a container for numerous animations. And what that container is called is a state machine. So if we right click and search for state machine, we can bring one of those in and we can rename it. We'll call this locomotion set. So this is going to be a state machine, a container for all animations pertaining to locomotion. So we'll connect that. And if we compile, we'll see that Raph will just go back to his default pose. And we get a warning on the locomotion set saying there was no entry state connection in locomotion set. So it's basically wanting us to put some stuff in the locomotion set so it knows what animations we want to see. So if we double click, we go into a new blueprint layout. This is essentially where we're going to be creating states for our animations. So we have this entry pin here. This is basically going to connect to our very first animation that's going to play. So the first animation we want to play is our idle animation. So we're going to actually, first of all, create a state, and we'll call this state idle. Okay, so our first state is going to be idle. If we jump into our idle state, we're going a few layers deep now, so keep up. We see another blueprint layout similar to the one we saw at our initial top layer of our anim graph. So similar to that, we can connect our idle animation. So we'll go play Raph idle. And if we hit compile, there we go, Raph's back in the idle state. So essentially, when our game starts, we've essentially created the same logic as we had at this stage when Raph idle was plugged in, but we can expand on it because we're inside a state machine that can hold numerous animations as opposed to just connecting this one individual animation. So we'll actually just delete that. We don't need that there. We'll go back inside our state machine, back inside our idle. That's all good. Let's jump back out. Now we want to create another state that we can transition to. So we'll drag off of our border here to add another state, and we'll call this one run state. And if we jump in here, we can add our run animation. All right, compile and save. We'll jump back out to our locomotion set. So now we've got two states, and we've got this connecting arrow between them. So this arrow just means that we can transition from idle to run. So we want to drag off from our run back to idle because we also want to be able to transition from our run back to our idle. So now we've got two transitions. But the problem is we don't have any logic that will state under what conditions do we transition from idle to run. So the game is never going to know, when do you want me to play this run animation as opposed to this idle animation. So now we need to kind of build a little bit of logic to state the criteria under which we're going to move from idle to run. And we're going to put that logic into this transition rule. So if we double click in here, we get to yet another blueprint window, and we have a warning. And the warning says, idle to run will never be taken. Please connect something to can't enter transition. So what we need is a piece of data to connect to this result that says, this is the criteria under which we want to transition. So what that rule is going to be is essentially, I'm moving, I'm running, I have forward momentum. That's the node we want to connect, so that Unreal knows, okay, now you're moving forward. Now I know I can transition to the running animation. So for that, we need to go back to a different section of our animation blueprint, and that's the event graph. And this is where you can build out some logic that will allow us to generate a piece of data that we can use in that transition state, which will allow us to transition. And hopefully this isn't sounding too wordy. Hopefully this is making sense. If you do it yourself, it definitely helps in your understanding. But I think a lot of you are you're computer science students, so you have like an understanding of programming vernacular. This is building out blueprints is essentially visual programming. So a lot of this hopefully is familiar to you. So by default, we have these two nodes. We don't really need to use them, so we'll actually just delete them. What we want to start off with is we want to start off with a node called begin play, event blueprint begin play. So when we hit the play button, this node is going to fire. And what we want to happen when this node fires is we want to access our player character. So we need to add another node called pawn, try and get pawn owner. So when the game fires, we want to gain access to our player character. And once we've done so, we want to validate it. So we can type in valid, we can click is valid, and this will just make sure that there is a valid pawn in our scene. And if not, if there is no valid pawn, the logic will just stop and it won't keep trying to search for a valid pawn. So assuming we have validated it, we want to capture that data in a container. So what that container is called is a variable. So we want to capture that pawn data in a object variable. So we can go down here and we can create a new variable, and we'll just call it pawn owner. And there's all different types of variables you can create. The one we want is a object. Object. So now we've created this variable, we can drag it into our scene and we want to set it. We want to say that this validated pawn owner is what our variable is. So if we drag off here, drag this into pawn owner, now we've set, we've taken this, we've gotten our validated pawn owner and we've captured that in a variable. So now we can access this variable elsewhere in our blueprint. One thing to mention is if your graphs here start getting a bit too messy, like you start to see wires overlapping with others, you can just double click on the wire and then like reorganize it as such. So to keep things kind of looking clean. Okay, so the next node we want to add is update animation. Event blueprint update animation. So what we're going to do is we're going to get our pawn owner, that data we captured, we're going to get it. And again, we want to validate it. So we'll add a is valid. Actually, we'll drag off here and add is valid. This one down here. We'll connect our execution pin. And assuming it's validated, we will we'll run a sequence. We'll add a sequence node. So a sequence node is just kind of like a graph management tool. So rather than have your graphs extend out to the right forever and ever and ever, using a sequence node allows you to extend out your logic more vertically. So basically, it's going to do things in sequence. It's going to do this piece of logic from then 0. Then from then 1, it's going to do this piece of logic, and you can add pins. You can add pins as many as you want. So it just allows you to kind of like extend your logic further down as well as to the right, rather than just like this infinite line to the right. Okay, so we're going to duplicate this pawn owner and drag it over here. And what we want to do is we want to get the velocity of our pawn owner. So we can type get velocity. Actually, let's see. Oh, hang on a second. I've got to compile first. I think if I compile, no. Hang on a second. Actually, sorry. I'll do get velocity without. I can't spell. Sorry. No, it's still not. Hang on a second. Just checking my notes here. Target is actor. Context sensitive. Okay. I don't think I had to do that before. That's a bit strange. I'm not sure what happened there, but so when you are dragging off of when you're looking for nodes to add, generally you want to have context sensitive on so that like it's only when you drag off of for pawn owner, for example, it's only going to give you access to nodes that are relevant to what you've drug off of. You don't want to be able to add a node that doesn't work with what you've what you've drug off of. So the only way I was able to get velocity in this circumstance was by turning off context sensitive. I feel like I didn't have to do that before, but oh yeah, see that's not oh, you know, I think okay, hang on a second. I may have made I think I know what's wrong here. Okay, I think I may have set the wrong type of variable up here. So I'm gonna actually just delete this here. And what I can do is actually, the other way to make a variable, I'm gonna delete this variable here. And if I promote this to a variable, okay, yeah, that was, yeah, okay. It was, I had made the wrong type of variable. So let's just rename this to, what was that? It was pawn owner. Oh, come on. So under variable type, I believe I had it set to object rather than pawn, and it needed to be pawn. So I think that's actually the preferred way of making a variable is by actually dragging off of a pin and promoting whatever you have drug off of to a variable, rather than making a variable down here, because it kind of ensures that you're going to be making one based on what you drug off of, capturing that data. So that seems to my mind seems to be a safer way to do things. So anyway, I think this is going to work now. So now that we've done that, we can get our pawn owner, we can plug that in. And if we duplicate this, and yeah, see now we can get the velocity of this pawn owner. Okay, perfect. So basically we're getting the velocity. So this is the velocity in all directions for this particular pawn. So again, we'll drag off here. We'll promote this to a variable. And we'll plug in our first sequence pin to this one up here. We'll call this one character velocity vector. Okay, and from here, now that we've set this this velocity vector, this velocity in all directions, let's get it. And we only really want the velocity of the character in the horizontal direction, or the x and z, or x and y in this case. We don't want up and down velocity. So we just want to extract everything except for z velocity. So to do that, we can actually add a pin called break vector. And then we can reassemble the velocity vector with only the pins we need, with only the axes we need, which are x and y. So we can now do a make vector. And if we plug in X and Y and leave out Z, that will just ensure we're going to be getting just the data of our horizontal plane. So once we've done that, there's one other node we need to add called vector length. And once we got the vector length, we can promote this to a new variable. And we'll call this variable horizontal speed. So this is effectively just the velocity in horizontal in on the horizon, no up and down, which is exactly what we want. So we'll plug in our execution pin. So now we've got a speed data captured. So we know that when Raph is moving around, it's going to give us his speed data in X and Y. But what we really want to know is if that speed is either moving or completely static. So we don't need to know all the different specific speeds at which he's moving. We just need to know, is he moving or is he not moving? So for that, we need to create one more variable, and that's a Boolean variable, which is just like a yes or no. Is he moving or is he not moving? So from the speed variable, we can just check if the speed is greater than 0. So if it's greater than 0, we can then set a variable that says, yes, he's moving. If it's less than, if it's 0, he's not moving. So basically we can add a node called greater than. So this is going to check if this horizontal speed is greater than 0. And if it is greater than 0, we want to create a branch here. So if we plug this this pin into the condition here of the branch. So if our horizontal speed is greater than 0, if it's true, then we want to create a new variable that says we are moving. So we'll create a variable here, a Boolean variable. This one I know is definitely a Boolean. And we'll call it is moving. And we can drag that in here and say set is moving. So if our speed is greater than 0, we are moving. So we'll plug that into true. And we'll tick off is moving. That means that it's true. And conversely, if it's false, we'll plug it in here and untick moving so that it's false. So let's compile all of that. And our compiler didn't turn to green, but that's just because it's still giving us warnings from the transition rules from the anim graph portion of our anim blueprint. So we're going to update that so we can get a green check up here. So just to recap what we did, when the game fires off, it tries to get the pawn owner, it validates that pawn, and if that pawn is valid, it sets the pawn as a variable. Then every time the animation updates, we again check if our pawn owner is valid, and if it does, we get the velocity of that validated pawn. We break that velocity down into just horizontal velocity, and we capture that in another variable called horizontal speed. And we check if that horizontal speed is greater than a value of 0. And if it is, we're moving. If it isn't, we're not moving. And now we can use that data, these two values, or this yes or no, are we moving or not, to use for our transition. So let's go back to our locomotion set. I'll close this one down. Close that. And jump into our transition rule for idle to run. So from idle to run, we want to go from idle to run if we are moving. So we can get our is moving variable and just plug that into that node there, or that pin there. And if we compile, now Unreal is happy. And if we go back to our transition the opposite way, same deal, get is moving, but we can just add on a not statement before that. Not Boolean. So if we're not moving, if we let go of W or A or D or S, W, A, S, or D, we'll transition back to idle. One other thing, if you have all your pins kind of offset like this and the flow isn't clean, you can just select them all and hit Q, and that will line them up nicely. So now we have our idle animation. We have rules to transition from our idle animation to our run animation. That's plugged in. And we have rules to transition from our run animation back to our idle animation. So let's see if that's actually working. So I'll just save this real quick. So now if we hit play, we're idling. And as we move forward, we start to run. We stop, we go back to idle. And we can actually visualize this in the graph that we were just looking at. So if I hit Shift and F1 when I'm still playing, that gives me mouse control. I can go back to my window here. I'll just make this a bit smaller. And you can see right now, idle is highlighted. When I start to run, it should transition to, the highlight should transition to run. And of course it doesn't. And the reason why it doesn't is because we forgot to select under preview instance, you want to select our third person character. So now, yeah, you can see we go idle when they were completely still, and then we
Quick
run.
question here. Is it, when you're moving from idle to run, is it moving the parts to where it starts, like naturally, or is it snapping to it?
Oh, you're talking about like how much is there a blend, like a blend over
Yeah, is there
time?
like a blend between the two that it's like naturally doing using the model skeleton, basically?
Yeah, you can change. I'm trying to recall. Yeah, you can so yeah, if you actually click on the transition itself, if you want to play around with how long it takes to blend from the idle to the run, you have blend settings duration here. So you can actually like crank this up if you want this blend to be smaller. So it doesn't it's not altered by, I think you were saying the skeleton. It's actually something you would adjust in the transition rule itself. So if you
Very
wanted a
cool.
longer blend or a different curve blend, you can pick from all these different sorts of curves. You can have a more linear blend. If you set this to, like, if I set this to, let's just, yeah, we've stopped there. If I set this to 0 and set this one to 0 as well, that will be like the snappy instantaneous blend you were talking about. Let's see. Yeah, you can
Oh
see
yeah,
now
it
it's like,
jumped, yeah.
yeah, so you probably don't ever want that.
No, for
But you can
sure.
play around with these blends. Um,
Still, the fact it's doing it is cool.
yeah. So what time are we at? We're at 3:25. Okay, I think we probably have time. Like I wasn't, this is where I was kind of like unsure if we had to have time to do this or not. Um, I want to leave like maybe a little like 15 minutes to kind of just wrap up and leave time for any questions.
For sure.
But one other thing we can do quickly is we can actually talk quickly about blend spaces. So blend spaces are actually containers that allow you to plot in several animations um, that you can blend between. So um, let me give you an example. First of all, let's create a blend space, a blend space first. So I'll go back to my atoms folder, close that out. And if we go under animation, legacy, blend space 1D. We'll assign that to our RAF skeleton. We'll name it BS RAF run. So this is the use case that I'm going to demonstrate for this particular blend space. So when we're playing the game, we see that when Raph goes into his run, he just runs at like that one animation we authored speed. Like we just have one set speed. But we all know in real life, people don't start out running at their top cadence of running speed. They build up, they walk a bit and then run. Or there's at least some sort of build up. So a blend space allows us to build build a blend of animations between, you know, a walk and a run, or any number of things like a lean, a standing straight to a lean, which you can then plot into your state machine and have it so that the running kind of lines up with the momentum you're building up in game. So if that's confusing, I'll show you. I'll make it more clear. So we have to export one more animation to do that. So we'll grab a walk animation. I have RAF armed walk. We'll open that up. And that looks like that. I'm just going to turn that off. So he's just walking on the spot. We'll quickly export this. Same as always. Where is my game exporter? There it is. And we'll call this just RAF walk, 60 frames, desktop, choose that, skeleton, export. Cool, we'll import, select animation, RAF walk, open, RAF skeleton, import. Did he come in on his back again? Yes, he did. Okay. Go down here, rotation to 90, and re-import animation. Errors we can ignore. We have a walk. Sweet. Okay. So let's go back to our blend space run. So in here, similar to some of the other windows we've looked at, similar to the animation window, here we have this kind of graph down here, which allows us to plot in any number of animations we want to blend between. We just want to blend between a walk and a run. So first of all, you can see down here we have 0 to 100. This range is going to identify the speed over which we want the animation to blend. So the top speed is set right now to 100, but that's not actually the top speed of our character. If we go back to our third-person character and we actually go over to details and look for max walk speed, we see that the max walk speed is 500 centimeters per second. So if we go into the blend space, this 100 is means centimeters per second. So let's set our max walk speed to match up with what our max walk speed is on our BP third person character. So if we want to change this, we just go over to our axis settings, horizontal axis. We can rename it. We'll name this, we'll call this speed. And we'll plug in, actually we'll change our maximum axis value. We'll change that to 500. Grid divisions, 4 is fine. We can have snap to grid. Snap to grid just makes it so that when you, like if I pull in my animation now, we'll start with a walk. You see this little gray dot is kind of going between these gray lines. Excuse me, I'll just delete that. If we turn snap to grid on, it will just snap them. I prefer having snap to grid on to snap to whole numbers. So it's actually going to snap right to 0. So at the low end of the scale, at 0, he's going to be walking. At 500, he's going to be running. So how do we visualize this transition? If you just left click and drag on your graph down here, nothing happens. You got to hold down control, and then you'll see this, now this green X is following you around. If you actually left click and drag, you'll see now we can visualize our blend. So you can picture this as your speed is picking up, as Raph is picking up speed, he'll slowly transition to full speed. Now there's a bit of jankiness in here, like you'll see this kind of wobbles a bit. It's kind of, I'm not quite recalling how to fix it. I believe, let's see if I actually change, if I pull this back like that, I don't know that that's going to change it. Yeah. Anyway, I won't go into that right now. It's not something the way to fix that is kind of eluding me right now. I think it has something to do with if you export, if your animations match up as the same duration. I think like, let's see, our run is 80 frames and our walk is, yeah, our walk is only 60 frames. So I believe a good starting point to ensure that two animations blend well together is to ensure that they're the same length. So, yeah, that's a little error we made here. But yeah, if you decide to start trying out this workflow yourself, just know that it's probably better to blend between animations that have the same duration. But anyway, let's go back to our blend space. We can save that. And now let's go back to our anim blueprint. And instead of run, we can disconnect that. And instead we can plug in our blend space, which was called BS RAF run. So we click that. Oh, that's the wrong one. Yes, run. So we want that, yeah, blend space player, not just standard blend space or blend space evaluator, blend space player. So if we plug this into the result here, you'll see that this blend space has an extra pin here. So essentially, how Unreal will determine what speed or what animation we're playing or how much of a blend is playing is based on a variable that we plug into speed. And we've already created that variable. If you remember back in our event graph, we created this horizontal speed. So this is calculating the horizontal speed in all directions. So depending on what speed Raph is going in all directions will determine how much we're blending. So if he's moving very quickly forward, like around 370 centimeters per second, he'll play that. If he's just building up speed, he'll play this animation. So all we need to do is get our horizontal speed and plug that in here. And again, I'll just line those all up. Q and compile, and we can delete that. So now let's go back to our workspace. And if we hit play, you can see that there's a bit of, it's not super noticeable. I'll make it more noticeable so you can notice it, but you can see that he's actually very quickly blending from the walking speed to the running speed. And I'll actually show you again how to visualize that on the graph itself to prove that it's actually happening. So if we open up this again, and just like before, we want to make sure that we have under our drop down, this is selected. So you can see that node there, the green X is moving gradually to the right. So that's the speed at which we're hitting our max walk speed. And you can actually tweak that. So if we go back into our blend space player, if you want to make this blend a bit slower, see right now that X, like I'm moving, if you see the white plus sign, that's me dragging. And the green X is the blend, is how long it will take the blend to occur. So if I want to slow that down a bit, I can go to, where is it? Smoothing time. I can set that to like 1. And then now you see there's that faded green X, which means that the blend is going to be a bit slower. So let's see how that looks in our game. Let's go back here and hit play. Yeah, you can see if you look at the blend space node again, you see that the more faded green X is a bit slower. And you can see that in the workspace, Raph is kind of hanging out closer to the walk animation before he gets to the full speed run animation. So that's how you play with those blend durations. So that's blend spaces in a nutshell. We have like 20 minutes left, so I probably don't have time for this, but there is another type of blend space, which is a 2D blend space, which gives you both a horizontal and a vertical axis. And you can use that for like if you wanted to add leans and stuff. So a lean based on a speed. So for that, you'd basically have like the same node here, but you'd have 2 pins to plug in, 2 inputs. One would be speed and one would be direction. And you would have to go into your event graph to generate a variable that calculates what direction you're going. And so that blend space would now be based on, would blend between a walk and a run, but also a left and right leaning animation based on what direction you're going. So it's a bit more complex, but if you understand like the essential philosophy behind a basic 1D blend space, 2D blend spaces are not really that much more complicated. Um, so yeah, let's see if there. I think that's basically all I had to show you in Unreal for now. Let me just check. Um,
It is too.
that's really it. Yeah, have a little bit of a wrap up, but if people have any questions at the moment or comments or whatever, we can prioritize those. It's nothing really super that we can't do without. But I'll give people the chance to if they want to
Okay, I
have
got a
questions.
question here. Uh, so, uh, you can ask your question.
Yeah, okay. So sorry, just trying to figure out how to phrase it.
Okay, I'll wait.
No, I think I've got it.
Okay, he's got.
Say you had like a fantasy game or something and you had a wizard character who had a walking animation with walking and then a animation for casting a spell where they pushed out their hand or whatever. Could you use blend spaces or something like that to fuse those 2 animations, or would you have to have a dedicated animation for walking and casting at the same time?
No, you could have separate animations that blend together. So this is a whole nother subject. So let's see if I can summarize this in a way that makes sense and also quickly. So essentially, up to this point, the animation assets we've been dealing with are called animation sequences. There's another type of animation asset called an animation montage. And those are generally used, those are generated from animation sequences. So you export your animation, you get an animation sequence, and then if you want to make an animation montage, you make one from the sequence. The use cases for montages are more one-off type animations, such as an animation where a character casts a spell. With those montages, you can actually, they're a bit more robust than sequences in that they allow you to say only play this animation, this montage on the upper portion of the body, but keep the character playing their locomotion running on the lower half. So you can author an animation that's a full body wizard casting spell, but you can ensure that it only plays on the upper half of the body because you want the legs to keep running if the character is running, or if the character is standing still, then you want um, the entire the entire character to do the full body animation. Does that make sense?
That's great. Thank you.
Yeah, that seems super cool. So that you can have him running, and then like the top half does his casting animation, and sort of mixes the two at like the waist, basically.
Yeah. So essentially, animation, locomotion stuff type of stuff is what I would say is most used for state machines, and one-off animations such as like you know taking a buff or something, or like doing an emote, or casting a spell, or throwing a punch. Those are what you would use animation montages for because they're just one-offs that don't happen that often, or don't happen as often as your locomotion stuff, and they allow you to blend to pick certain parts of the body on which they occur and other parts that they don't occur on at certain times. So it's really a subject that requires a lot more um time to really fully dive into, but that's like the general gist of things.
Super cool. All right, I think we have another question here.
You said before that there was someone who mentored you when it came to Unreal, I think. You said their name was Skylar Serva. I, you said that you were going to also link us to some tutorials. So where could I find that?
Yes. So that Agora link that I sent you, um, if you go to their YouTube page, they that's where there is a Skylar Sura gameplay animation playlist that lays out a lot of what I talked about here, as well as like more stuff. Um, and as well as like there's a bunch of other mentors there who teach other animation, not specific to game animation, but if you want stuff that's more like gameplay animation focused, go to the Agora gameplay animation um, YouTube site, or sorry, Agora YouTube site, and then you'll be able to find that stuff there.
Sounds good. Sweet. Any other questions? Raise your hand. I'll come over to you. Okay, I think it's quiet in here now.
Okay. Yeah. So I hope this was informative. It's really just kind of like a mishmash of stuff I've gleaned over my 16-year career. I think as far as like the Unreal side of things go, I'm still very new to it. So that's why I kind of weighted things more towards Maya. But I think if you want to be a gameplay animator, you should probably dedicate, you know, maybe as much time to whatever engine you want to work in as you would to like creating the art itself, because there's actually tools in Unreal 5 where you can literally animate in engine itself. Like I'm just only starting to delve into that, but you can actually on your skeletal mesh you can build what's called a control rig, and while it's not quite as robust and doesn't have all the you don't have all the scripting power that you have in Maya, it's very quickly becoming gaining tools, and tools are being introduced that are rivaling some of the digital content creation software, which is like your Maya, your Blender, your 3ds Max, what have you. So I think that's another area to if for aspiring gameplay animators to learn about is learning to animate in engine, because again, as I stressed, being fast is very very important. And honestly, like just transitioning, having to go from one piece of software to another creates often can create little issues like we ran into where I couldn't import that scene that just wouldn't be as likely to occur if you're just staying within one piece of software. So I'm not saying that the future is going to be completely within Unreal animating and everything. People have their comfort zone that they want to work in, but I think it's you definitely don't want to be closed minded to like new ways of working. It's really important to kind of keep abreast of what new tools are coming out, and I think Control Rig is one of those things that gameplay animators who want to work in Unreal should be focusing on.
For sure, yeah. That sounds sick. I'm definitely gonna have to rewatch the whole workshop with like the workshop in one window and then Maya and Unreal in another one on my desktop later.
Yeah,
work
absolutely.
work through it step by
Um,
step. Um, I did have a question. So, do you do much modeling yourself as well, or is it mostly the animation?
Mostly animation.
Okay, then never mind.
Yeah, I'm not the person who's going to have any amazing insight into that. But as far as like, yeah, I do know a little bit about rigging. So for those of you who want to learn about who want to become gameplay animators or just interested in rigging, I mentioned a tool before called Advanced Skeleton. It's
Yes.
fantastic. I don't know if you've heard about it, but definitely have a look at that tool. Um, it's it's kind of like, I guess some of like the real hardcore riggers don't consider it rigging because it's basically like an auto rigger. But
Yeah.
I think if you want to be a gameplay animator, it's probably a good approach because you can get rigs that are probably good enough for an indie studio. So, in the interest of gaining a little bit of rigging experience to supplement you as a gameplay animator, Advanced Skeleton is a good low investment for a high reward. Is
Sweet.
what I'm trying to say.
That sounds
Um,
good.
yeah, and another thing I want to say is that I think you guys are know I'm sure you're very aware of like the state of the industry and how a lot of studios have been doing like crazy layoffs and stuff like that. And it's I don't know how you all folks feel about it. I imagine you don't feel great for those of you who want to go into game development hearing all about this, but um, in my experience, there's definitely been ups and downs throughout my 16 years. And granted, this one has probably been one of the most challenging. I've been lucky to not be affected, and hopefully that continues. But I think like the best thing you can do in your downtime. I mean, you're still students, so maybe you're not quite ready to like start going on the job hunt. But just make sure you're keeping building up your skill set and staying like getting involved in communities like Discord is awesome. Agora has a Discord as well where the people are posting all sorts of work. And I think animation, like I said, is very collaborative. And you want to, if you want to become a really solid artist, you want to be staying in the community and keeping your ear to the ground about what things are new and changing. And building up your network is one of the best ways to get jobs. Like a lot of the jobs I got were through just, people knowing who I was and saying there's an opening here. Like I taught for several years, as I mentioned, at VCAD, and that job just came along when I was working in another studio and somebody recommended me. So yeah, don't, you don't, you're not only going to be a valuable asset based on your artistic skills, it's also your interpersonal skills. It's about what people know about you, and it's about like the network you build for yourself. So I highly encourage you because a lot of us are working in a remote world now, or maybe not having as much uh, interaction with others. But you want to make sure you get involved in in your communities related to your profession as best as possible. Like in Vancouver, we have a monthly animation meetup that that occurs at a local restaurant, and it's a great opportunity just to kind of like see people in the flesh and just catch up and stuff. So
That's super
I don't
cool.
know what kind of community is out in Kamloops, but definitely make sure you stay involved in that.
Sure. Sounds good to me. I suppose, yeah, I don't, I think we're out of questions here, and that all sounds really good.
You
Um,
got
did you have any more wrap up you wanted to do, or is that the gist of it there?
um yeah, not really. I mean, I think anything more I would talk about would be like more substantive, like more show you more stuff in Maya, but it doesn't seem to really make sense at this point. So,
Sure, yeah.
um,
Okay, fair enough. Yeah, no, absolutely. It sounds good to me. Obviously, thank you for helping me adapt to Air Canada's cancellation of its flight there. Um, Next year, hope you're willing to come in person because we probably want to run this again next year. It'd be great to have you here.
yeah,
Uh,
I'd love to.
yeah, and I mean, if you know of anyone else in different like focuses as well in the game industry, uh, there's tons of like potential that we're always looking for as far as like speakers go as well, right? So definitely like
For sure.
we,
I
we
am curious about the students who are there. Are how many of you are there people who are actually considering a career in animation, or like what is the breakdown in terms of areas of game development that they want to get into?
we're like 90% are probably computing science students, so probably programming side of things, and then I think maybe
Yeah.
there's like a 10%. Yeah, there's probably like a 10% for of the 10-20 year that are more artsy focused.
Okay. Cool.
Yeah,
Yeah. I
but
think.
no, like any of that though, obviously is like, especially if you're like you're saying with the indie teams where you have to sort of wear multiple hats, right? So learning about any part of the game design spectrum for a day is incredibly useful to us who don't have like access to a game studio nearby to be part of a larger team.
For sure, and especially like if any of them wanted to go into solo dev or smaller teams, then yeah, that being more versatile is going to be a huge asset. So
They want to
yeah,
be
I
at the
mean, I wish
next
you,
lethal company.
yeah, yeah, absolutely. Yeah, I mean, I wish you guys luck. I don't know how much more time you have in the program, but I wish you
Yeah,
the best of luck.
thank you so much. Okay.